So in our last recording on Langgraph, we saw how we can create a reflection um, pattern by having a agent which generates the response. That the response is reviewed by an evaluator. The review results are shared with the response generator. The response generator improves upon the generation based on the review, again generates it, and it goes on for. So in the last recording, we did 4 turns before we ended it. Right. In this recording, we'll see how, or we'll extend that process, like after the response generation and the response evaluation. After this turn is done, the final improved response, we will give it to a, I'll not say it's a memory evaluator, it will say memory, I'll say it's a memory manager. So the memory manager will store it into a memory store, into a memory store, which say it's a semantic memory store. And this is what we'll see as part of this recording. And this memory store has been created using Pinecone. And for the semantic memory, I found a very simple and beautiful semantic memory implementation. It's called simple memory. What it does, it uses OpenAPI for embedding the memory key and uses Pinecone to store the semantic memory. So Pinecone, we'll see how to create an index in Pinecone and get the API key also. But after we do a pip install of simple memory, to add memory, we create a instance of the semantic memory, and then we call the add memory item function of semantic memory to add the memory key. So in this case, the memory key is what is the capital of India. The memory value is the capital of India is New Delhi, right? So what it does underneath, it creates embedding of this question and stores the question and the answer. So when we try to retrieve for the semantic memory, it has a retrieve memory item function where if we give the memory key, which is a question, it does a semantic matching. It does an embedding match with whatever is stored in the semantic memory store and retrieves the top match and returns the key, which is a question, the answer, and the score of the match, right? So this is what we'll use for the memory manager for adding the memory. And the memory store is Pinecone, right? As if you see here, we use this, we need OpenAPI key, we need the Pinecone API key, and we need a Pinecone index. So let's see how to create the Pinecone index. If you go to Pinecone, you can create a, for your learning and testing, you can just create a free tier of Pinecone. And once it is created, you can, when you click on index, you can create an index. We'll name our index memory. And since we are using the text, the add a large embedding, which is 3072 dimension, okay, 3072 dimension, and cosine similarity is what we'll use. So we'll create this index. Now, once this index is created, now I can go back here. So here in the .env, I don't want to show the .env because there are certain API key. The .env, what I have done is exactly like how it has given, right? I gave the Open API key. I gave the Pinecone API key, which you can create by clicking on API key here, and then create your own API key. And then the Pinecone index, I gave the name as memory because that is what I have created. You can name it anything, but for me, the memory index name is memory, right? Now let's go to the code and see how I have done it. So if you see right now, the memory store is empty. There is nothing. Let's go through the code. So it is exactly like the previous one, except that I added the memory step. So in the previous recording, we went through the reflection agent. So the reflection agent has a generate answer, which generates the answer. It has the critic agent, which critiques the answer so that the generate agent can improve on what it has created, right? And I have added the add to memory agent where I'm creating an instance of the semantic memory, exactly like how it has been mentioned here. And then I am adding the memory item with the original question and the improved answer, the final improved answer. Now, if you see in the previous reflection agent, if the turns are done, if the 4 interaction iterations are done, right, then we used to return end, right, end the workflow. Instead, I'm now returning this node, this agent, add to memory, so that after the interaction between the generator and the reviewer is done, the final improved answer can be added to the memory through this function, right? So I have added the node generate answer, the critic agent, the add to memory. Entry point is our generate. This is the entry point to the workflow. This is the conditional age. Generate agent goes to the conditional age. If it is less than 4, it will give it to the, it will return critic agent. It will go to the critic agent. Critic agent will again give it to the generate agent. But after the 4th turn, it will return add to memory, and add to memory is the finish point, right? That is all that is there as part of the workflow. Now I run this workflow. So everything is same as the previous recording where you saw reflection agent. This part is new, where I said the set finish is add to memory. Instead of return end, I put the return as add to memory because that is what the last node would be. And I added this add to memory node, right? Now when I run it, you'll see how it populates the memory, right? So let me run it. Let's say I say a question is, what is blockchain? So the generator will create the answer, the critic will critique it, generator will create it based on the review comments, it will recreate the answer, and it will continue 4 interactions between them. So that's why we have total 8 messages, right? So each turn has 1 answer from the generation, 1 from the critic, right? So it will go on for 4 interactions. And after that, we'll see that the memory add to memory agent will store it in the memory. So once it is done, there's still going on. The interaction between the generator and the reviewer is still going on, right? So once it is done, we'll go to the memory store, which is on. So it is done now, right? So add to memory has finally added. So let's see what it added. So if I go to my point phone, now if you see what it has done is this. So it added the first memory. So if you see, if I edit the vector, this was the question, this was the memory key, and this is the value it has stored, right? And this is the embedding of the memory key. So I can now add a memory router in front of the generator, right? So if I find the embedding match with the question, right, based on a threshold score, I can directly give the answer instead of going through multiple 4 turns. Maybe in another recording, I'll show how to create the memory router, but this recording is to show how we are populating the memory, right? So let me ask another question, and we'll see that another memory will get added. Let's say, what is quantum computing? Again, back and forth between the generator and the reviewer will go on. So generator agent has answered. So now the reviewer agent will, the critic agent critiques it, generator agent will create it again. Then, okay, so yeah, critic agent is critiquing it. It will go on for 4 interactions. You see here, yeah, the critic agent is critiquing it. Generate agent created it again, critic agent critiqued it again, then generate agent created it again, right? This will go on for 4 interactions, and finally it has been added to memory. Now, if I go to the memory, I should see the second memory that is added, which is what is blockchain. Yeah, what is quantum computing. So here also what is computing, quantum computing, and this is the final improved answer. So this is what I wanted to show, that as part of the Langgraph workflow, if a process is running, the memory of the process after the improvement can be stored in a memory. And I used simple memory. That's a package which implements semantic memory. It's a very cool implementation, very simple, right? And Pinecone, the only thing is it is using Pinecone as a memory store, right? And in the Pinecone, the memory items are getting added. So that's what I wanted to show today. So finally, if we see what we have seen is the response is generated, evaluator evaluated it, or the critic critiqued it, gave it back to the response, and it went in for 4 times, 4 interactions, and finally the memory manager stored it into Pinecone, which is our semantic memory store. That's all. Thank you.